Hey, this is Mr. Hanson. I wanted to talk with you today about number systems. There are different ways that we count things and different ways that we use numbers. Um, and each of these ways, I used to kind of think that they were chronological in order, that there was a historical timeline to how they developed, but I don't know how true that is anymore. I think they just developed as a matter of need. And let's just go through them so you have kind of an understanding of what they are, and then we can talk about how there were some discoveries made in the number system. So if we start off with maybe the most basic number system, you always start by counting with one, because when you're counting things, you don't have a reason to count them unless there's at least one of them. So you don't start with zero, you start with one. And you can use symbols to represent 2, 3, 4, 5, 6, 7, 8, 9, and so on, like that. These are called counting numbers or natural numbers. And you can imagine that these were helpful in the earliest of times. They help sheep herders keep track of their sheep, or cavemen, or whatever. But it was kind of hard when we're starting to develop symbols for each of these numbers. As your numbers get larger and larger and larger, you'd have to have more and more symbols. So someone came up with this idea of zero. So that's saying zero ones, no ones. Kind of a revolutionary idea that there's nothing of something. So zero ones, one one, two ones, three ones, and so on. And then when we get up to 10, you can kind of see the relevance of this. Now we're saying 1, 10. And 10 was used probably because people counted on their fingers. And so we're saying one set of fingers plus 0 fingers. And one set of fingers plus 1 finger. So it's 0 is kind of like a placeholder here. And that helps with counting, with adding and subtracting and regrouping. That just makes things much, much easier. So whole numbers was kind of a big leap forward, those people who knew how to use whole numbers. And people started thinking about negative numbers, especially when it came to borrowing and lending money. So here are the set of negative numbers, and you can see we call these integers. And then we had people who kind of put these on a number line, and they wondered if there were kind of some spaces in between the numbers, and so 1/2 or 0.3. So these are called rational numbers. And let's just talk about these. So if the natural numbers is a set of numbers, I'm going to kind of use a Venn diagram here. Well, let's make it sort of small so we can fit everything on the page. So just, oh, that didn't work. Let's try it again. Okay, sorry about so this is natural. 1, 2, 3, dot, dot, dot. Now the whole numbers contain all the natural numbers, but they also have 0. That's whole. And the integers contain all the whole numbers, but they also have negatives. And the rational numbers contain all the integers. So if you think of like 1, that's 1/1. It can be written as a fraction. So anything that can be written as a fraction. All these other numbers could be written as fractions. And then you also have decimals. You have repeating decimals. You have fractions. So anything that can be written as a fraction is a rational number. So as people were kind of using the number system, they ran into something interesting. For example, if you were working with whole numbers, and you're using the different operations, and you come across subtraction, and you go 5 minus 7. Well, you can say 7 minus 5 is 2, and you're subtracting two whole numbers, and you're getting another whole number. But if you say 5 minus 7, now you're not getting a whole number anymore, you're getting an integer. So part of discovering new number systems was based on doing operations with maybe older number systems. And if you have a number system that when you do an operation, it stays in that number system, we call that a closed number system. It's closed. So, for example, whole numbers are closed under the property of, or under the operation of addition, because when you add two whole numbers together, you just get a whole number. And they're closed under the operation of multiplication, because when you multiply two whole numbers together, you just get another whole number. But whole numbers are not closed under the operation of subtraction, because when you subtract two whole numbers, it's possible that now we're moving into a different field. We're moving into the integers. And whole numbers are not closed under the operation of division, because as soon as you do that, you're talking about rational numbers. So that's kind of an introduction to the number system. There is one more kind of number I'd like you to learn about, and that's called irrational numbers. So numbers that cannot be written as fractions. So we're going to kind of put them out here. Irrational. And it might be easiest to take a look at this in terms of area. So if you had a little square here that's kind of offset, what's the area of that square? Well, you can kind of see that it has like about this much area, because we've got 1, 2, 3, 4 of those little half squares. So about 2. So the area is 2. And you might remember a square, it's a side squared equals the area. So s squared equals 2. So what number times itself is 2? That's kind of the question we're asking ourselves here. What number times itself is 2? And it's kind of hard to think of it because it's what we call an irrational number. But we kind of made a convention for it. We just said square root 2. That means that whatever number, this number times itself would be 2. So square root 2 times square root 2 equals 2. And if you put square root 2 in a calculator, you get something like 141, and a lot of decimal places after that are just ongoing, okay? So this irrational number, it can't be written as a fraction because the decimal has no repeating pattern to it. So you can't change the decimal into a fraction. Square root 2 is the most accurate you can write it, most accurate way you can write it. So square root 2 is irrational, square root 5 is irrational, square root 3 is irrational. Is square root 4 irrational? What number times itself is 4? Well, that's just 2, so that's not irrational. These are all irrational. There's another irrational number that pops up a lot. This is when you take the circumference of a circle and divide it by the diameter, you get what we call pi, which is about 3.14. It's also an irrational number. So this is the number system here. These are all called real numbers. These are all real numbers, and I'm going to kind of leave you to think about that, and then we'll talk about, we're going to extend this a little bit in the next video. Thank you.